All right. Thank you. Hello, everyone. Welcome to this talk, Kubernetes for Data Professional. My name is Abdellfetah SGHIOUAR. You can just call me Abdel. I'm a cloud engineer with Google. I've been in the cloud space for 4 years now. You can follow me on Twitter on Board Abdel, and I'm also a podcast host on a podcast called the Cloud Careers Podcast. And today I'm going to talk to you about Kubernetes, but I'm an infrastructure professional. That's basically my background and what I do. But I'm just going to try to attempt to explain Kubernetes to people who are in the data space, to which Kubernetes could look like this massive, complex piece of infrastructure that no one really knows how to use. And so we're going to have a basic 101 level explanation, and hopefully this could be a good segue into to help you actually dig more into the topic. So what is Kubernetes? Kubernetes is an open source project. If you ever looked into it, it usually says this thing. It's a container orchestration tool. And what we mean by container orchestration is essentially a tool that would allow you to manage multiple containers at scale. The whole point of Kubernetes and the whole reason why it was introduced is because when you are writing and developing and deploying an application which runs on top of containers, if your application has 1 or 2 or 3 containers, it's probably easier. You can use something like Docker Compose, and you can just like orchestrate the containers, manage them, manage in which order they get started or stopped, manage the scaling up and down, etc. But if you have hundreds or thousands of containers in production, then you need something better than just doing it manually. It's designed to run everywhere. Run everywhere means that Kubernetes itself, the open source code is written in Go. It's compiled for a lot of platforms, x86, ARM, and different CPU architectures. So you can pretty much run it on anything between a server, a Raspberry Pi, or a computer under your desk. You can even run it on your machine directly using tools like Minikube or Kind. And the whole point of Kubernetes is that it introduces a certain level of abstraction from the infrastructure. So you as a user, you can actually focus on the application and not on the underlying virtual machines or the underlying nodes. I'm going to talk about that in details. Why Kubernetes? Why people like to use it? Because it guarantees workload portability, or at least workload portability within the same sort of CPU architecture. If you build a container, you know that basically if you do a Docker container on your MacBook and you take the Docker container and give it that image and give it to a different person, as long as they have a container runtime on their computer, as long as they are on the same sort of CPU architecture, so x86 or ARM, they will be able to run that container. And that's kind of what Kubernetes also guarantees, that between multiple installations of Kubernetes that are on the same sort of operating system, on the same CPU architecture, your containers will just run the same. As I said earlier, it introduces a certain layer of infrastructure from the abstraction from the infrastructure. So as a developer, you don't focus on figuring out where to run a specific container. You just focus on writing your code, building it as an image, and then you tell Kubernetes what you want to do, and then Kubernetes will figure out where and how to do it, and then it will monitor your application and make sure it's up and running all the time. It's pretty modular in the sense that a lot of components in Kubernetes itself can be replaced. Talking about some basic components like DNS, for example, you have multiple DNS plugins, things like the scheduler, which is a part of the Kubernetes control plane, which is a part of sort of the brain of the system that decides where your containers are going to run, that makes sure that all the containers that you want to be running are running all the time. That's called a scheduler. There is a default scheduler, but you can swap it out for something that uses different algorithms. It's actually built with this idea of being declarative and not imperative, which means that you as a user or as an operator, as a developer, what you do is you tell the system what to do, and that's the declarative part. You declare your configuration in the form of YAML, and in that YAML, you say, for example, I want my container to be run, and I want to run 3 copies of it. And that's how the container looks like. What's the name? What's the image? What environment variable this container has, what volumes for storage this container has, etc. And then Kubernetes will figure out how to do that for you. So you don't actually tell Kubernetes like, hey, please run this container on this node and this container on this node. You just tell the system your declarative configuration, and then the Kubernetes will figure out how and where to run that for you. I went to Google and I looked up about what are the things that data professionals care about. And this stuff came up. Again, I'm not an expert. I'm just trying to appeal to you. So basically, most data applications tend to be stateful. Stateful means that they manage some sort of state, so they need storage. People in data space seems to use a lot of databases. They seem to use a lot of data processing frameworks, which are slightly different than what probably application developers use. And these are things like pipelines to manage data transformations, pipelines to sequence in which order transformations will be applied on some sort of data and stuff like that. And machine learning obviously is like one of the big ones. And so Kubernetes has in mind, maybe you would have, if you have used Kubernetes before, you have seen all the stuff you can do in a stateless part of Kubernetes, which is using deployments, and then rolling up or rolling down, and auto-scaling application, which are great for stateless applications. But for stateful applications, Kubernetes also has a certain set of components that can allow you to run stateful applications. So stateful application, if you have been in the data space for a while, you have probably used some of these tools like MapReduce, Hive, Spark, Hadoop, and stuff like that. And the common thing between these sorts of tools is that they allow you, they tend to be very specialized and they do one thing. So if you run a Hadoop cluster, that Hadoop cluster will only allow you to run Hadoop compatible stuff, and you cannot do anything else with it. And that tends to mean that this cluster is going to be underutilized because they can only do Hadoop things. They cannot do anything else. And typically all the data frameworks that exist on the market have a common thing, which is there is no really compatibility between the tools. The way something like Hadoop works is different than the way something like Airflow work or something like that. What Kubernetes does is that it gives you a way to standardize how do you run this application. I'm going to be very specific here when I mean standardization. So think about use cases where you want to run some Hadoop workloads, but you need a database, right? If you do a Hadoop cluster, you will have to basically provision a different set of your infrastructure where you're going to run your database, and you're going to have to maintain two sets of tools, two sets of scripts to manage the different infrastructure. Just because you cannot run database on your Hadoop cluster, maybe you can. Maybe somebody can tell me. Kubernetes can allow you to standardize that by basically running everything on the same piece of infrastructure, which is Kubernetes. That's where you have all your databases, all your data processing frameworks, all your machine learning processing frameworks, and then you just use the same standard tooling to manage them, to monitor them, etc., etc. Kubernetes was released by Google in 2015, and it was an inspiration from this tool we had internally called Borg. Some of you might have heard about it. It is essentially our internal version of Kubernetes, which we used for years, and we use it to run containers at scale. Pretty much every single Google product you have used before or you are using right now runs on Borg. And the same inspiration actually drove the design, or at least the initial design of Kubernetes. And some of the designs are still kind of there since they were designed. Some stuff have changed. I highly recommend you to go and look into Kubernetes design principles, because there are like some guidelines in terms of what Kubernetes should and should not do. And Borg itself has a lot of white papers that have been published by Google, so you can just type Google Borg and then you can read about Borg. So how would you run stateful applications on Kubernetes? So Kubernetes has this thing called stateful sets. A stateful set is a way to run a predictable known set of workloads that have specific network identifiers, specific stable persistent storage. And that goes back to the part where I talked about abstraction. In a Kubernetes world, if you need to run a container and then attach a volume to it, which is like an NFS volume or like a Samba share or something like that, you don't really have to tell the cluster how to manage that persistent storage. As a user, you use higher level objects. In the case of storage, is something called volumes, and you create a volume, and then that volume will provision the underlying disk space to be able to store your data. And then you can take the disk space and attach it to your stateful set. You can also use stateful set to order in which order your pods are going to be started and shut down. You can also use it to ensure that you have graceful termination for your pod, because by default, sorry, I started using the term pod. You can just think about pod and containers are the same thing. in the world of Kubernetes. We don't talk about containers as much. We talk about pod, but pod is just a container in which you have multiple containers. In a Kubernetes environment, if you have an application which runs as a stateless application, you should expect that your containers will be terminated at any moment in time due to the changing nature of the underlying infrastructure. A node could go down, all the containers running on that node would be down, and then the scheduler will detect that and will figure out how to reshuffle your pods or your containers such a way that they keep running. In using stateful sets, you can actually tell Kubernetes that before doing a shutdown, whenever it's possible, gives you a signal to which your application can listen and then do some last minute, flash data to disk stuff and things like that, or like finishing some calls to some APIs and stuff like that. It allows you to do also automated rolling updates, and all of this is built in. All of these mechanisms that I talked about are part of the core API of Kubernetes. You don't have to do anything special about it. Then Kubernetes comes with this very powerful concept called operators. And so operators are essentially a way for you to use the same sort of API as Kubernetes to build your own custom stuff. So let me give you a very, very good example, which is you want to write an operator that creates a database, for example. And you want it such a way that creating the database for your users becomes as simple as just creating an object called database and giving it to Kubernetes. By the way, one of the things, if you have used Kubernetes before, one of the things you might have not noticed or maybe know is that when you create an object that Kubernetes knows, so when you create an object that is part of like the mainstream API, like a deployment, a service, etc., and you submit your object to the API server, which is the kind of core component, one of the core components of Kubernetes, the API server will just say, okay, I know how to create these deployments. I know what the deployment is. I know how to create it, and it will create it for you. If you are trying to create your own custom objects, then you create something called CRDs, custom resource definition. And in your custom resource definition, you're just telling the API server, hey, there is this object called blah, and my object blah has these settings, right? And then there is a piece of code called operator, which runs inside the cluster. So if somebody tells you, please create a copy of blah, then you know that this operator is responsible for it. And then you just pass that object to the operator, and the operator will take care of creating it. So this could be, as an example, I gave databases. It could be something like, I want to use Kubernetes to actually provision a bunch of virtual machines. So you have to create a CRD, a custom resource definition that says VMs. And then the customization you will want to give your users are things like the IP, the names, amount of storage, the operating system, etc. And then you write an operator that actually implements the actual calls toward whatever infrastructure you have to make those virtual machines creation happen. And then later on, your users will just submit an object to the API server called virtual machine, and then that virtual machine will be provisioned automatically. And so there are a lot of operations in the market out there. ACCD is one of them. Surprisingly, ACCD is actually one of the most common things in data space, but Kubernetes itself uses ACCD. What I mean here is ACCD that you can run on top of Kubernetes, not the one that is already built in. You have Prometheus, you have Kafka, Postgres, Elasticsearch, Redis, and so on and so forth. So these are the already written, already open source operators, and then you can also write your own. It has some native integration with a bunch of open source tools. Spark on Kubernetes is one of them. Jupyter Hub, Airflow is already there. The slides are a little bit outdated. Some of the ones I used before are Argo pipelines, is already integrated, and there is a bunch of other stuff. In the machine learning space, there are things like Kubeflow. There are a couple of operators for TensorFlow and PyTorch. And there is a lot of other options for actually running machine learning workloads on top of Kubernetes. You could also, Kubernetes also support GPUs out of the box. If you run on top of cloud providers that have some GPUs available on their virtual machines, you could just create a cluster with GPUs attached to it, and then run your workloads. And then the workload you're going to run, or the container you're going to write, should just expect that there will be a GPU available in the environment that container can use. For the people who are interested in details, Kubernetes uses something called PCI Express pass-through, which means that the GPUs are not actually virtualized, that your workload gets access directly to the GPU die to be able to use. So recapping, Stateless applications, deployments and replica sets. I'm a little bit ahead of time. Simple stateful applications, you can use stateful sets. Distributed databases, you can use operators, and then you have a bunch of native integrations with tools like Spark, Airflow, machine learning, Kubeflow, etc., etc. And with that, I think we can take questions on the Slack channel. I will be on track 1 channel for a while and try answering your questions. You can always follow me. And if we don't get to catch up this time, we can just talk. We can just reach out to me on Twitter with your questions. I'll try to answer them. Thank you very much.